Hello, this is Abraham from EasyAutoDiagnostics.com. In this video tutorial, I'm going to show you how to test TPS1, TPS2, and the throttle actuator motor inside the electronic throttle body of the following vehicles: Buick Lucerne, Buick Terrazza, Chevrolet Equinox, Chevrolet Impala, Chevrolet Malibu, Chevrolet Monte Carlo, Chevrolet Uplander, Pontiac G6, Pontiac Montana, Pontiac Torrent, Saturn Aura, Saturn Relay, and the Saturn Vue. You can also find this list in the video description box below. Before we start, let me tell you that you don't need to remove the throttle body from the vehicle to test it. In this video, you'll notice that I have removed it, but I've done this only to better explain my multimeter test connections. One more thing, the absolute best way to connect the multimeter test leads to the male terminals of the throttle body is with jumper wires that have alligator clips on both ends. Okay, I'm going to start off by testing the resistance between terminals C and E. Both of these terminals are shared by TPS1 and TPS2. What I'm looking for is a resistance reading of about 1.5K ohms. If the multimeter gives me a reading of less than 1 ohm, then I can conclude that the circuit between these two terminals has a short circuit problem and that I need to replace the throttle body. Or if the multimeter gives me an over-limit reading, then I can conclude that the circuit between these two terminals has an open circuit problem and that I need to replace the throttle body. Okay, to get started, I'm connecting the red multimeter test lead to terminal C. And I'm connecting the black multimeter test lead to terminal E. I'm placing the multimeter in ohms mode. And as you can see, I'm getting a resistance reading of about 1.5K ohms. And this test result lets me know that there isn't a short circuit or an open circuit problem between these two terminals. Now, if the multimeter had given me a reading of less than 1 ohm or an over-limit reading, then I can conclude that the electronic throttle body is defective and needs to be replaced. The second test is to test the resistance between terminals D and E of TPS1 while I open and close the throttle plate. If TPS1 is working correctly, the resistance value should increase as I open the throttle plate, and it should decrease as I close it. If TPS1 is defective, then the ohms reading will usually stay stuck in one value as I open and close the throttle plate. Or the ohms reading will have gaps as the throttle plate is opened and closed. Alright, I'm connecting the red multimeter test lead to terminal D, and I'm connecting the black multimeter test lead to terminal E. I'm placing the multimeter in ohms mode. And as you can see, I'm getting a reading of about 2.7K ohms, which is good. Now, as I open the throttle plate, the resistance value should increase, and as I close it, the resistance value should decrease. Now, I'm going to push down on the throttle plate, and the resistance value should continue to decrease. Since the resistance value increased as I opened the throttle plate and decreased as I closed it, I can conclude that TPS1 is not defective. Now, if the resistance value had not increased as I opened the throttle plate or decreased as I closed it, then I can conclude that TPS1 is defective. My third test is to test the resistance between terminals E and F of TPS2 while I open and close the throttle plate. If TPS2 is working correctly, the resistance value should decrease as I open the throttle plate, and it should increase as I close it. If TPS2 is defective, the ohms reading on the multimeter will stay stuck in one value as the throttle plate is opened and closed. or there will be gaps in the reading as the throttle plate is opened and closed. Okay, I'm connecting the red multimeter test lead to terminal E, and I'm connecting the black multimeter test lead to terminal F. I'm placing the multimeter in ohms mode, and as you can see, I'm getting a resistance reading of about 2.2 k ohms. Now, as I open the throttle plate, the resistance value should decrease. And as I close the throttle plate, the resistance value should increase. Now, I'm going to push down on the throttle plate, and the resistance value should continue to increase. Since the resistance value decreased as I opened the throttle plate and increased as I closed it, I can conclude that TPS2 is not defective. Now, if the resistance value had not decreased as I opened the throttle plate or increased as I closed it, then I can conclude that TPS2 is defective. Okay, the last test is to test the resistance between terminals A and B of the throttle actuator motor. If the throttle actuator motor is okay, the resistance value should be around 2 to 15 ohms. If the throttle actuator motor is defective, the resistance value will be over the limit, which will indicate an internal open circuit problem. Or the resistance value will be less than 1 ohm, which will indicate an internal short circuit problem. Okay, I'm connecting the red multimeter test lead to terminal A, and I'm connecting the black multimeter test lead to terminal B. And I'm placing the multimeter in ohms mode. And I'm getting a resistance reading of 3 ohms. And this resistance value lets me know that the throttle actuator motor is okay in this throttle body unit. Now, if the multimeter had registered no continuity, or a resistance value of less than 1 ohm, then I can conclude that the throttle actuator motor is defective. Hey, thanks for watching, and if this tutorial was helpful, give it a like, and be sure and subscribe. Also, check out the links to more info and tutorials in the video description box below.